here mostly, and then a quiz. Okay, so number 7 on your notes there from Thursday. Name 2 triangles that are similar to triangle ABC. Then they want us to find the values of x and y. And then in parentheses I typed out, it may help to redraw the 3 similar triangles in corresponding order. So we're going to line up all the corresponding parts. So the first one, triangle ABC, that's the big guy. What kind of triangle is that?
Right.
It's a right triangle. So then my other 2 right triangles, DBC and DBA. Do you see both of them?
Yep.
Okay. I'm going to show you how you redraw them. Draw 3 right triangles. They don't have to be perfect. That look similar to each other, meaning they're the same shape, but not necessarily the same size. My first one is going to be triangle ABC, the big guy. Which vertex is at the right angle on triangle ABC? B. So I'm going to label the right angle B. It wouldn't matter where you put A or C on this, but I'm just going to keep it looking like how the original one is. So I'm going to put A at the top and then C at the bottom. The middle triangle is going to be my medium-sized right triangle, which is triangle BBC. So which vertex should I label at the right angle? D. Now looking at triangle ABC, the big guy, and triangle DBC, this medium one, which angle do they both share? Do they both completely use? C, right? Don't they both use C when I trace them? I trace the same 2 lines. Okay, so wherever C is on this picture, it needs to be in the same spot on my middle picture. So I'm going to put C down here, which means my top vertex must be B. They're the same angle, so I'm putting them in the same spot. My third triangle, see that's supposed to be a little bit smaller, is supposed to represent my tiny guy, ABD, which is my right angle on triangle ABD. D, so we'll put that as D. And comparing the huge triangle, ABC, with the little tiny triangle, ABD, which angle do those 2 share completely? A, good. So A is on the top of my first triangle, so I need to put A on the top of my third triangle. Therefore, my last vertex here will be B. Okay, so when we line them up in corresponding order, what we've done is put all the congruent angles in the same spot, which means the corresponding sides will be in the same spot. Remember, the biggest side is always across from the biggest angle. Well, AC is going to be the biggest angle of the first one. BC is going to be the biggest side of the second one. And AB should be the biggest side of the third one, because they're all the hypotenuse. So when you line these up, you want to put congruent angles in the same spot. Now, we're going to take all our labels and put them on these 3 triangles. So the length of AB is 20. So wherever I see an AB on my pictures, I'm going to put 20. BC is X. CD is Y. BD there in the middle, that altitude is 12. 88. What about the length of AC? Louder. Good, 8 plus y. You'd add whatever y is, so if y was 10, then that length would be 18. Okay, so what we've done is redrawn our triangles so that they're similar, and we've drawn the corresponding parts in the same areas. We're supposed to name 2 triangles that are similar to ABC. We're going to write an extended similarity statement. So triangle ABC is similar to triangle BDC, because everything is lined up already, which is similar to triangle ADB. Okay, there's your similarity statement. And then we have to find the values of x and y. X and y are representing sides. Since the triangles are similar, then I have to set up proportions. Okay, kind of like an extended proportion here, I have 3 triangles where I really only need to use 2 of them. You can pick. It's whatever you want to do. Do you want to use the first 2? Do you want to use the last 2? Or do you want to use the first and the last one? Or which one should we use for sure? The last one, right? Because it has all the numbers. So I'm going to use this one for sure. Do you want to use it with the middle guy or with the first guy?
Middle guy.
Yeah, because who wants to do 8 plus y, right? No one. I'm just going to cross that off for now then. So line up corresponding parts. X in the middle triangle there should correspond with what? 20. So x is to 20 as, go back to that middle triangle, 12 is to 8, as I'm going to make it an extended proportion, as y is to 12. Just pick 2 at a time to cross multiply. If I simplify this first, 12 over 8, what goes into 12 and 8? 4, so wouldn't that be 3 over 2?
Yeah.
So if I want to solve for x, 2 times x is 2x. 20 times 3 divided by 2, and x is 30. Wouldn't that make sense? 30 over 20, that'd be 3 over 2, right? Yeah. Okay. And then, now I'm going to do the last 2. So 12 over 8, I'm going to keep that as 3 over 2 equal to y over 12. Cross multiply 12 times 3. 2 times y is 2y. Divide by 2. 18. And I get 18. You will have a couple questions like this week. One for sure today on your assignment. You'll see another one coming up here soon. Right, similarity. You can redraw the pictures so that all the corresponding parts are in the same spot. Okay. All right, the next 3 are really similar to each other. Thanks. Number 8, a telephone pole that's 7 meters snaps into 2 parts during a windstorm. The ratio of the 2 parts is 3 to 2. We want to find the length of each part. So here's my telephone pole. Here's the dead wires here. Careful not to touch them. I guess they're not dead. They're still alive. Okay. This is the bigger part, so I'm going to put a 3 there. And this is the smaller part. This is going to be the 2. It's cut in a ratio of 3 to 2. If I were to smash the pole back together, it has to be 7 meters long, right? Okay. Multiple ways to write a ratio. We can write it using the word 2. You could do it with a colon, 3 to 2. I like the fraction way, 3 to 2. Those are all the same. Would 3x over 2x be the same as 3 to 2?
No.
Let's pretend x equals 4.
Yeah.
What's 3 times 4? 12. What's 2 times 4? What goes into 12 and 8?
4.
If I reduce by 4, what do I get?
4.
What if I said x was 10? Then this would be 30 over 20, which would reduce to what? So is 3x over 2x the same as 3 to 2? Yeah. If you multiply the numerator and denominator by the same value, it's still the equivalent ratio, it just isn't reduced. That's what you're going to want to apply to this ratio up here. You want to take your 3 times x and your 2 times x, because then you can make an equation. Using your segment addition postulate, the length of the first part of my telephone pole, 3x, plus the length of my second part, 2x, should equal 7. Combine like terms and we would get 5x equals 7. divide by 5. You could leave it as 7/5 if you wanted to. If you like mixed numbers, that'd be 1 2/5. If you like decimals, that'd be 1.4. It's a nice decimal. So that could be any of your x values. They want us to find the length of each part. Is 1.4 the length of each part? No, what do I have to do? Plug it back in. So if I go into the shorter one, 2 times 1.4,
2.8.
2.8. The longer one, 3 times 1.4, 4.2 meters. And 2.8 and 4.2 better add up to what? 7, because my telephone pole should be 7 meters in total length. I'm still using all of it way back from first semester that I wrote the segment addition postulate. But a ratio will always be the same even if you multiply both parts by the same value. So if I think about that for my next question, number 9, the ratio of the measure of 2 supplementary angles is 8:7. What does it mean if angles are supplementary again? They gotta add up to 180. Well, they're in the ratio of 8:7. So should I say 8 plus 7 equals 180?
No.
What should I write?
8 x plus 7x.
Good. 8x plus 7x should equal 180. The ratio 8x to 7x is the same as 8:7, but now I have a nice algebraic equation. 15x would equal 180. Divided by 15, and x comes out to be 12. Find the measure of each angle. 8 times 12, 96. 7 times 12, 84. And 96 plus 84 better add up to 180. Those angles are in a ratio of 8:7. If I were to reduce them down. Okay, try 10 on your own. Drew a picture, maybe it looks something like that. Side lengths of 5x, 9x, and 10x. The perimeter of this triangle is 120. How do you find the perimeter of any polygon?
Add up all sides.
Add up all the sides. So then your equation, 5x plus 9x plus 10x is equal 120. 24x would equal 120. Divide by 24, and what do we get for x? 5. Find the length of each side. What's the length of my shortest side? 25. How about the next shortest side?
45.
And my longest side?
50.
Alright. Try to remember your labels if they apply. Okay, side lengths, degrees. Try and remember your labels. Questions? Okay. Oh boy. I have one more thing.